Yes.
Yeah, yeah. Yeah, started the recording.
Yes. Okay, so we will start with module 3.2. Last time we finished with K-map. K-map is also called as Mac-Quincy method. Okay,
Yeah, yeah.
so Mac-Q method. So if you feel ki what is Mac-Quincy method, it is the same thing, K-map. Okay, so this K-map now we will be using to reduce any equation or whatever the relation truth table, like from any given condition I have the truth table, and from the truth table I want to implement the circuit. So what we will do, we will entry all those values in the K map, and then we will find out an expression, and from the expression now hence onward we will have a circuit.
Okay.
Okay, because we will implement all those things. Okay, so
Okay.
circuit will be there for everything. After K-map, I have an equation. So I will have all the combination of gates, AND gate, NOR gate, NAND gate, XOR gate. Okay. If unless if it is specified, use only universal gates. Otherwise, you can use any gates. Okay. So we will see all the options. So what we are going to do in module 3.2 is all various circuits are there. Arithmetic circuit, like we have half adder, then we have full adder, then we have half subtractor, full subtractor, and then we have look ahead carry adder. Like if I'm adding something and then that carry is added further. If I get a carry after adding, so that carry look ahead means, or if I am adding currently right now something, what is the previous carry, that also I am including. So that is my look ahead carry adder. Then we have BCD adder. Remember we studied BCD, which is
Yeah,
different, 8421 code. Okay, so if I have 8421 BCD, then how do I add? It will be little bit different from my normal binary adder. Then we have magnitude comparator. Like if I give you one binary stream and another binary stream, you give it to that comparator and then it will tell you which one is higher. Okay, so it will compare the magnitude. See, all the circuits are used in our system, whether it is a communication system, whether it is your PC and all. Okay, so various arithmetic functions are done. So we'll now come to know about the circuit. Okay, so starting with half adder, and you have to write it down and you will tell me once you finish writing, because what we will do, what is the logic that you will write the truth table. Once you finish the truth table, I'll show you the truth table, then you will do the K mapping. Once you do the K mapping, then there will be the circuit. So this will be the flow of every topic that you are studying. Okay, so we start with half adder. Now you might feel half adder, full adder. What is that? आधा addition होगा या full addition होगा? ऐसा नहीं है. Half adder, full adder is something to do with number of inputs and number of outputs. Okay, so in half adder, what is a half adder? So a half adder is a circuit which needs two binary input and it gives two binary outputs. So that adder is called as half adder. For full adder, it is three inputs and two outputs. Okay. Now, inputs I am taking over here. If you can see, X and Y are my two inputs over here. And then the remaining two columns, you can see, just see the truth table. It is C and S written. So X, Y are my two inputs. So 2 raised to 2, 4. That is 4 combination. So 0, 0, 0, 1, 1, 0, 1, 1. Okay, so that is my table. And here I have C. C stands for carry. And then S stands for sum. Okay, so whenever I'm adding, it will be a sum and then it can be a carry that is generated. So if I add 0 and 0, I get a sum as 0, carry is also 0. If I add 0 and 1, my sum is 1, carry is 0. If I add 1 plus 0, my sum is 1, carry is 0. Now here, the last case, when I add 1 plus 1, okay, the sum is 0. Okay, 1 plus 1 is 10 and I get a carry over here. So this carry is 1, okay, when both the inputs are 1. So this is the truth table of your half adder circuit. So you write down in your book, half adder means 2 binary input and 2 binary output. Okay, and then you draw the truth table. You can take AB as the input And C and S usually we use because carry ka C or sum ka S. Okay, so these are the two outputs. C and S are your two outputs. Okay, and then you draw the truth table.
Yes, madam.
Finished?
Yes, madam.
Glenn, finished?
Yeah, 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 ma'am.
Okay. Now, if I tell you to draw the K map and then find out the expression for S and C. So you have two variable. So two rows, two columns will be there. Take X and Y.
Yeah.
So if I want,
And four.
suppose, okay, so two rows,
0, 1.
two columns you can take X
Yeah.
and this is
And
suppose
0, 1, 0.
Y. Okay, you take it 0, 1, 0, 1. So for 0, 0,
0,
suppose I am finding out for sum. For 0, 0, it is 0. Remaining
0,
for 0, 1, it is 1. For 1, 0, it is 1. For 1, 1, it is 0. Okay. So I want to make the grouping, both ones are separate. So I have to make individual
1
grouping.
will be 1. 1
So
groups.
this will be one group and this will be the other group. Okay. So
Right.
write down the
7,
function.
equals to 0.
Similarly, you will do for C.
Yes, ma'am.
For C, and wherever there is 1, 1, you have an entry of 1. So just see what is the function you are getting.
Ma'am, there is zero disturbance. Hello?
For C also, so wherever there is both inputs 1, at the time I have output as 1. And so if I want, I will make grouping of this one.
Yes, ma'am. Yes, madam.
So what is the function? Can you tell you are getting for S and what is that for C?
Yes, ma'am. Ma'am, A dash. A 2.
Are you getting, Glenn, what we are doing?
Yeah, yeah, ma'am.
Yes. So what is the function? Just see your
A dash and
carry is XY, the last one which we did. Both are 1, so XY. And your S was coming out to be X dash Y. That was one block. one cell, and xy dash, that is the second block.
second.
Okay,
Ma'am,
so this was the sum and carry which we are getting from the K map. Okay, so you from the truth table you have to draw a K map, and from K map only you will get the expression for sum and carry. Now, if you see, now we have to implement. Think about implementing. Okay, using any gate. So C is X and Y. So X and Y are my two inputs. Okay, so X and Y is what? It is ANDed, multiplied. So here you can see that I have used a AND gate. So X and Y I am taking and I am giving it to an AND gate, and I am getting my output as C.
X and Y. Okay.
Here.
Uh-huh.
Okay. So I am getting my output as C. I am ANDing it. And then if I see x dash y plus x y dash, this particular function, it is an XOR gate. Okay,
Ma'am,
so
there
what
is
I do
some
is,
disturbance is
I
coming.
directly give it to an
Hello.
XOR gate over here.
Ma'am, the
Okay,
disturbance
so
is coming.
simple function. So I have an XOR gate, I have an AND gate, and I can implement this half adder circuit.
Okay. Okay.
So you draw the circuit diagram. Once you finish, you'll tell me.
Yes, ma'am. Hello.
For XOR gate, don't forget to draw that line.
Yeah,
This
yeah. Yeah, ma'am.
line over here.
Yes, ma'am.
Finished?
Yes, ma'am.
Okay. Now, suppose a question comes, implementation of half adder using a NAND gate. Okay, so or the next question can be using a NOR gate. Okay, so this question can be given to you. Okay, implement a half adder using NAND gate. So we require 5 NAND gates. So here instead of A and B, you can take X and Y. This I took it from a different side. So that's why instead of X and Y, it is A and B. Okay, so you can use XY, or when you are drawing at your end, you first draw the circuit, then what you will do, write the output after each NAND gate, and then you see sum S, which comes out to be A X or Y. So that is X dash Y plus X Y dash, and carry is X dot Y. So first draw the circuit. So I have two inputs and I have 5 NAND gate combinations. So draw this particular circuit. Now why we are going for this particular, because in the previous one I required two gates combination, XOR as well as NAND. Suppose if your office or your lab does not give you different gates, they tell you we have only universal gates. Okay, and you should be able to implement using only universal gates. So that's why you require to know the how we can do it. You can give numbering to all the gates. The first NAND gate on the left side is 1. The top one you can give it 2. Middle one 3. 4 you can give it to the sum IC, and 5 you can give it to the carry.
Yes, ma'am. And then.
Now once you are drawing and you have finished drawing, start writing the output of each and every NAND gate. Don't expand it. You can just write, like for the first NAND gate, you can write A dot B dash, whole dash complement, because NANDing. So A dot B, the whole complement. And then if you see, so here write the output A dot B, the whole complement. Okay, output of this, you can give it first NAND gate, this is second, third, fourth, the last one is 5. Okay, so I have given names to all the NAND gates, 1, 2, 3, 4, 5. Output of first NAND gate is A dot B dash. Now let us see how the carry is generated first. Okay, so if you see, from here to here, the carry is coming. So A dot B, and again, it is given to a NAND gate, which is complement. No, both the inputs are shorted. So it is A dot B complement, the whole complement, so that both the complement goes away and you are left with A dot B.
Yes, ma'am.
Is this clear, Glenn?
Yeah, yeah.
Yes. Now similarly for gate number 2, you have A dot B whole complement as one input, and you have A as the second input, and that both of them are NANDed together. So here you have A dot AB whole complement. Okay.
Yes, ma'am. And then here we get is complement
Yes.
goes away for X.
Similarly, you write for 3, it will be B dot AB complement, the whole complement.
It will be, my case is Y, ma'am. Y dot X, Y. Whole complement.
Yes. And then you write for the final one,
Yeah,
See,
one
what you
column is
can
left.
do is you can take this as x, you can take this as y, and then here it is what nanding. So x dot y,
Not an
the whole complement, that is, and then you can substitute the value of x, you can substitute the value of y.
Yeah, my friend.
So you should be getting a dot b plus a b dash. That is my XOR gate.
Yes.
Are you getting it?
Yes, madam.
Oh. So implementing half adder using NAND gate, you remember for getting the carry, I दो बार नैंडिंग करना है. ए बी एक नैंड गेट में जा रहा है, उसका वापस कॉम्प्लीमेंट करेंगे, तो इट विल गिव मी a dot b, because since it is NAND gate, it gives me output as a dot multiplication and the complement of it. So दो बार करेंगे तो that complement is removed, so I'm left with the product ab. And for getting x dot a dash b plus a b dash, what I have to do is once NANDing I am doing, then that NANDed output I am taking one of the inputs to another NAND gate और वो वापस से दूसरा input दूसरे NAND gate में दे रहे हैं.
Yes.
And ये दो जिसका output आ रहा है, that is your IC number 2 and 3, which was that I am giving it to a fifth NAND gate or fourth NAND gate in our case, and I'm getting the sum. And I'm using the Boolean identity, De Morgan's law, for getting this function. Now, same question they can give you, implemented half adder using NOR gates. So here also the scenario is almost the same.
Before not get
I will require 5 NOR gates.
file objects.
So what you do, now you do it yourself.
Yeah, yeah.
Give the numbering 1, 2, 3, 4, 5, and try to get the carry, try to get the sum. Now see, NAND गेट में ANDing के लिए दो IC चाहिए था डायरेक्टली.
उसमें
ओके,
एक ही हो जाए.
यहाँ पे सम के लिए, बिकॉज सिंस और no, it is used XOR function हो रहा है ना, and it is using NOR. So for getting the sum, I require two stage like this one. If you see this IC and this IC, so it gives me the sum. So to get the sum, I require two stage. But to get the carry, I will require
One stage will be
four, after four things. It is exactly the opposite compared to your previous one. Once you finish, you tell me.
Yes, ma'am. Done. Yes, ma'am. Done. Interaction.
See, output of first or NOR gate gives me A plus B the whole complement. It's OR का invert. So A plus B the whole complement. ऊपर वाला NOR gate का is A complement. The third IC gives me B complement. So A complement, B complement, it goes to the fourth NOR gate. Okay, so I have A complement plus B complement as my input, the whole complement. So according to De Morgan's law, what happens is that plus becomes multiplication and the variable का complement हो जाएगा. So complement of complement, so A complement complement का A हो जाएगा, B complement का B हो जाएगा. This part and this part. So I am applying De Morgan's law over here. Yes, so similarly do it for the fifth IC. So here one of the input is A plus B
Plus.
complement, whole complement, and the other input is AB.
Yes, ma'am.
Okay, so the fifth gate we have one input as A complement plus B complement, and the second input is AB. You give, you can take this as X and that one as Y, and then you can simplify. So here you should get, since I'm working with AB, A dash B plus AB dash.
Yes, ma'am. Done.
So is this done?
Yeah, yeah.
Oh, now we will go with the full adder circuit. Okay, so for full adder circuit, we have three input variable and two outputs, so sum and the carry. Now what that they are telling in full adder is, if you read the theory just beside, two of the input variable x and y. So that represents the two significant bit. Okay, like the previous one, I had the two inputs x and y. So here also you have the two inputs as x and y. Okay, and the third input variable, which I call it as z over here. Now what is z is, it is the carry from the previous lower significant position. Okay, so right now don't bother about it. So in short, your full adder has three inputs x, y, z, and then two output, that is the sum and the carry.
Yes, ma'am.
Okay, so you can draw the small block diagram, write x, y, z. So half adder has two inputs, two output. Full adder has three inputs, two outputs. Now let us draw the truth table. Okay, so you will make the truth table x, y, z, three inputs. Then we have the sum and we have the carry. So three inputs. So first draw the input table 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So this is my standard three input truth table. Then we will, once you enter the truth table, then afterwards you write the value of sum and carry after adding all those things. Today we will do half adder, half and full adder only. Next class we will do half subtractor, full subtractor.
Okay, ma'am.
Now let us see the truth table. For the first row, I have 0, 0, 0. So I add 0 plus 0 plus 0. So my sum is 0, carry is 0. And the second row, I have to add 0 plus 0 plus 1. So it is sum is 1, carry is 0. Then the first, second, third row, 0 plus 1 plus 0. So my sum is 1, carry is 0. Now in the fourth row, I have 0 plus 1 plus 1. So 1 plus 1 is, sum is 0, carry is 1. Okay, this
Sum is 1 and
fourth one. Then I have 1 plus 0 plus 0. So the sum is 1, carry is 0. Again in the sixth column, I have 1 plus 0 plus 1. So 1 plus 1 is sum 0, carry 1. The
1, 1 again same.
second last, again I have 1, 1, 0. So it is 1 plus 1 plus 0. So my sum is 0, carry is 1. The last one,
1, 1, 1. So ma'am,
1 plus 1
sum
plus
and
1.
minus
So
carry.
my sum is also 1 and my carry is also 1.
Yes, ma'am.
Is the truth table clear, Glenn?
Yes, ma'am.
Oh. Now, once you have the truth table, what you will do is K-map. So, three variable K-map. So, there will be 8 cells. So, you can take X, Y, Z or X, or you can take X, Y on one side and Z on the other side. It is up to you. Like you can take x, y on this side and z on the other side. So here you have 4 and here you have only 2 and here you have 4. So I should be having 8 sets. So this is 0, 0, 0, 1, 1, 1, 1, 0 and this is 0, 1. Then you enter the value. First you find out for carry or whichever one you want to do, and then you same another K map. You have to draw 2 K map and then you have to enter the values and find out for sum.
Yes, sir.
Glenn, if by chance the session ends, we are not rejoining because it is 40-minute session. So 40 minutes
Okay,
का
ma'am.
lecture हो जाएगा.
Okay,
So
ma'am.
no need to join.
Okay, ma'am.
Okay, and then again I'll continue from that portion which we have left.
Okay, ma'am. Ma'am, should I stop the recording?
Yes.
Should I stop the recording?
No, no, not now. At that time, once we disconnect, at the time you record, save it.
Okay, 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 ma'am.
Okay. So now just see your key map.
Yeah, ma'am. Yeah, yeah, I did.
So here, instead of x, y and z, they have taken x, y, z. That is also possible.
Yeah.
Now, once you do that entry, you have to write the function. So there are 4 ones in both. The first one is for the sum. This is for the sum. This is for the carry. So you have the truth table with you. So from that, you enter the values. And then try to form the grouping. For the first case, could you make any group?
One moment.
No. All 4
One.
are in 4 corners. This is one corner. This is one. This is one. This is one. I am not able to make any groups.